If you ever open a React project that you've probably seen a file like this with TypeScript, this feels suddenly like you're reading a different language. But here's the interesting part. This file is actually one of the easiest place to learn because almost everything here is describing the data, not building the application. So instead of memorizing the syntax, today we're going to reverse engineer how this TypeScript file is created. First, we're gonna start here in our type aliases. You can see here tile, letter, string, points, number, and ID string. This is not creating a tile, it's creating a blueprint. Think of it like an architectural plan for a house. It doesn't build the house, rather it simply says if you will be creating a tile, it must contain first a letter string, second a points number, and an ID string. Does the same idea also appear here in our board tile? You can see here in our board tile, it also appeared here in game summary. Next, we're going to go to our primitive types. They simply describe what kind of value is allowed. If we're going to see letter is equals to string, it means only as text. While we see points as number or the score, it only means number. So this allows TypeScript to catch mistakes before you even run the application. Next is our optional properties. When you see this question mark, this just pertains, it may exist or may not exist. A while ago, we have seen here our board tile has an optional pending and optional preview. So that question mark is really important because it means that it's only optional. So if you see an example data, this is letter and points. This will be a valid example. But if you also see letter A and points 1 and pending true, this is also valid. What only becomes invalid is when this letter and points is not declared inside because they must be required. Next is our union types. So our union types is basically, this is one of the coolest TypeScript features. Instead of saying this can be any string, our project limits only to these values. So it can be TW, DW, TL, DL, or it can be a star. But it cannot be outside of this declared inputs. So this prevents bugs and gives much better autocomplete while coding. In short, union types are declared limited allowed values. You can see here in our example, like here, game summary, turn is only accepting two types of input, either the string your turn or second string their turn. Outside of this, we will get an error. Next is arrays and type annotations. So this simply just means that this wrap is an array where every item must follow the tile blueprint. Remember our blueprint tile? If you can see it directly in our example, here is the rock tile. So every item here must match the game summary type. To here, see our game summary. So we are creating a game variable and we're assigning it to a type game summary. This type was created here at the top where it must follow exactly the blueprint we declared. So if we created here, this is the exact creation of the data. So the little colon here that we are seeing is called type annotation. So it tells TypeScript exactly what kind of data this game's variable is. So the type of this game's variable is game summary. So other common example is for our wrap receives a type annotation. So every type annotation in TypeScript is to be preceded with a colon. Next is our record key value. This is like a dictionary type, like in Python. So probably this is one of the strangest part or syntax that we encountered so much here in this. So ignore the syntax for a second. Think of it as like a dictionary. This points to a key and value example. So the same pattern appears here in again. Record string number, record string number, record string premium. So it tells coordinates Like this string, premium, this is a premium square. So it's the same idea every time. This keys string maps to values that we have here on the right. Basically, this is like an object. Next is our function types. Our function types, basically this is just functions that is used inside TypeScript. In practical application, if in our Grep Premium, we are seeing here this input as numbers because we see here type of numbers. We are also seeing here in Premium, this must be the return type. So TypeScript is documenting the function before you even read the implementation. So we see here parameter types and then the return types. Next is type assertion. So ascons is basically tells you that the TypeScript to keep the exact value instead of treating it as generic string. To keep the exact value. So here, as number, there must always be exactly two numbers. Perfect for storing coordinates. So if you notice something about this file, that this file is not about doing calculation. It's describing data. That's the real purpose of TypeScript. JavaScript tells you how your application wants to do, but TypeScript tells your application what the data should look like before it even starts to run. So once you understand these concepts, type aliases, object types, union types, arrays, record, function types, ascons, you'll understand almost most of the common TypeScript feature we generated in this project. That's exactly how I recommend learning TypeScript, not from textbook, but by reverse engineering real projects.